And welcome, pre-calc. Oh, that wasn't that good. What's tomorrow's date? I'm recording this. Clear that. Come on. Clear that. Clear. Don't need a text from Mr. Keister. Pre-calc, January 22nd. January 22nd. Let's do some notes. Wow. E-Day number 2. There we go. You're number 1 in a world of number 2s. Okay. Hey, we are studying 5.4. No, I cannot recreate that sound for the we. 5.4 is just called trigonometry. Let's do intro to trigonometry. There we go. I'm just making up stuff now. Okay, so hey, you guys, I'm going to try to keep this video to under 15 minutes. I mean, this is a pretty exciting topic, so I'm really going to try. But you guys need to take a picture at the end of this and email it to me, and that's how you're going to get your points, just like last time. Way to go. And there might be an extra credit somewhere in the video. Also, okay, so there we go. 5.4, Intro to Trigonometry. Okay, so back in the day, a triangle wasn't called a triangle. It was called a trigon. Okay, so that just means triangle. Okay, and then metry just means measurement. Measurement. And that's all that means. We're just going to study the measurements of triangles. So all the different things that a triangle that you can measure. Well, there's not that much. You can measure 3 sides and you can measure 3 angles. Like really, that's it. So it seems like so easy. How could there be question after question after question or classes after classes after classes about trig? That's because there are so many properties that are tied in with trigonometry or just these 3 basic sides and 3 basic angles that it just kept on expanding and expanding and expanding, okay? And so, so it's just the, we're just going to study the measurement of triangles, okay? Triangle measurements, whatever, however you want to think about it. But that's what trigonometry means, okay? So here's the thing. We're going to use some Greek letters like this. This is theta. Theta, T-H-E-T. Boy, my handwriting's bad. I'm trying to watch the Kansas City Buffalo game right now as Kansas City's up by 3. It's 7:43 in the p.m. Sunday night. And then another one that we're going to use is like a fancy B, and that stands for beta. Okay. Now, I also might use maybe the fish, the sideways fish. That's gamma. I don't know if I'll use anything else. I mean, we can use regular letters also, but those are 3 that I'll use. Where am I at? Only 3 minutes deep into this problem. Okay, so do you guys remember the Pythagorean theorem? I sure hope you do. Pythagorean theorem. And basically all it said was, if this is A, this is B, and this is C. Then across from big A is little a. Across from big C is little c. And across from big B is little b. Right there, okay? And all it said was that, oh, maybe I should re-letter these, dang it, because it's not going to match what you guys, it's not, yeah, it's not going to match. Okay, Mr. Keister keeps on texting me. Let's see, what do I want? I want this to be B. So then this would be little b. And then this is C. So then this is little c. Can you hear my phone? Hang on a second. Okay, and I'm back. We're at 5 minutes. All right, so this is what you've heard for the Pythagorean theorem. Little a squared plus little b squared equals little c squared, okay? And in other words, side squared plus side squared equals hypotenuse squared. Ooh, another fancy word. This is the hypotenuse. Hypotenuse. And there we go. Or instead of side squared plus side squared equals hypotenuse squared, it could be leg squared plus leg squared equals hypotenuse squared. Okay, so that's cool right there. That is the Pythagorean theorem, and we're going to use that. Now you need to also be aware of something called Pythagorean triples. Sorry, I'm getting distracted because Buffalo just scored. Pythagorean triples. And I would say that this is a must memorize for you. We haven't even got to the good stuff yet. Pythagorean triples go like this: 3, 4, 5, or 5, 12, 13, or 7, 24, 25, or 8, 15, 17, or 9, 40, 41. What in the tarnation does that mean? Well, if this is A, like if this is the A column, and this is the B column, then this is the C column. Okay, so like I could bust out a calculator, but I'm not going to because those are some big numbers. But I could go like this. I could say 3 squared plus 4 squared equals 5 squared. Don't believe me? What's 9 plus 16? Oh, it's 25. That was a terrible 5. BTW. Huh, how about that? So Pythagorean triples are used all the time, and they're multiples. In other words, also like if I multiplied all these sides by 2, I could also say like 6 squared plus 8 squared equals 10 squared. Don't believe me? What's 36 plus 64? Is it 100? You know it is. How about that? Okay, so just the multiples, but you got to multiply them all by the same number. Those are called Pythagorean triples. Okay, so we haven't even got to the good stuff yet. Here we go. There are some key ratios. He keeps on texting. There we go. There are some key ratios. Ratios is just sorry. There are some key ratios. I just keep on getting texts now that everything got canceled. And the key ratios are sine, cosine, and tangent. Okay, and so sine, all it means is just a fancy word. I don't know why they picked sine. They just did. I don't know, and I don't even know who they is, do I? No. But sine is opposite over hypotenuse. Cosine is adjacent. Ooh, that's a fancy word. Over hypotenuse. Tangent is opposite over adjacent. And now I swear it's 7:50 p.m. on Sunday night, and some little kids just ran down the high school hallway. I think it was Miss Huff's kids. Opposite over adjacent. And they looked in here, and it was not Miss Huff's kids, but they looked in my hallway. They looked into my classroom, saw me sitting down and talking to myself, and darted the other way. That is so funny. Okay, so sine, cosine, tangent, and I really don't know whose kids they were. Never seen them before. It's okay. All right, so those are the key ratios. Like that's so super important, okay? But then there are some minor ratios that I will call, I guess I'll call them minor ratios. Minor ratios. And they are the flippy flip. Okay, so sine goes with something called cosecant. So it's hypotenuse over opposite. And then secant is the flippy flip of cosine. So it's hypotenuse over the ADJ. And then the last one is cotangent. And cotangent is the flip of tangent, and it's adjacent over opposite. Okay, those are so important. Like memorize that. Oh, I'm watching, hang on, number 11 caught the ball way downfield. Patrick, dodging, throwing, catching, number 11, boom, down. And the Buffalo still has the lead, but Kansas City is threatening in the third quarter with 20 seconds left. Handoff to number 10, Parchenko, and nothing. Okay. Anyway, these are key ratios or major ratios and minor ratios, whatever, but this side is what I'm going to focus on. Now let me explain what those words mean. Okay, you can't just say sine. You have to have an angle after it, like sine angle A, or cosine angle B, or tangent angle whatever, tangent theta. Okay, so you can't just have the word. You also have to have an angle after it. Okay, so and let's get those to go away. There we go. So let's draw a right triangle, everybody. Where am I at time-wise? Oh, crud, I'm not going to make it at all. Okay, so here I go. Choom, choom, choom. I know I promised 15 minutes, but I got distracted, and that triangle was so bad. That was like the worst right triangle in the... That's not any better. Ugh. Okay, let's put theta up here. And let's use one of those triples, like 5, 12, 13. Okay, this will be our example because I promised a 15-minute video and now I'm getting distracted. Too many distractions. Okay, so if I said, what is the sine of theta? You don't put the E. It just looks like sin theta, sin. But it's sine theta. Well, that would be opposite over hypotenuse. This is the hypotenuse because it's across from the right angle, right? Okay, so sine of theta would be 12/13. Okay, okay. If I said, what's the cosine of theta? Well, cosine is adjacent over hypotenuse. So this is the adjacent, the leftover. Okay, I always label the opposite and hypotenuse, and then just with the arrows, okay, and then the adjacent's always the leftover. So adjacent would be adjacent, or sorry, cosine would be adjacent over hypotenuse. And then last but not least, the tangent of theta is opposite over adjacent, 12/5. Leave it like that. Don't do anything with that. And you're like, well, that's doggone easy, right? That's really doggone easy. Yeah, it sure is. But hang on 1 second. Or, well, it's just going to take just a little longer than 15 minutes. I promise. We're so close. But I have to punch this idea through your brain. I don't care how bad that triangle is. Here's the right angle. And I know it's still the same triangle, 5, 12, 13. But this time, let's call this beta. Okay, well, if that's beta, now if I said, what's the sine of beta? Well, the sine of beta, now the opposite has changed. Do you get that? This is opposite. This is hypotenuse. So then the sine would be 5/13. The cosine of beta would be adjacent 12 over the hypotenuse, 13ths. And then the tangent of beta would be or opposite, sorry, opposite over adjacent, which is 5/12. Oh, touchdown. Pachinko. Sorry, 5/12. Wow, what a heck of a game. Okay, and so that, I promise, man, is 1542. That is the end of the notes for today. There is a ton more to do. There's a ton more that we get to do here with all this trig stuff. It's really cool. I really enjoy it. But now I must say to you, good day.